Discover the Unity architecture. When we talk about deploying the EMC Unity VSA, one of the things that we want to discuss is the deployment to VMware. When you deploy to VMware, we have two options. We can deploy to a multi-host configuration with a vCenter that sits on top. The other is to deploy to a single host. We're going to first start with showing you a vCenter deployment with multiple physical hosts. Well, what do you get when you do that kind of deployment? First and foremost, you get hardware redundancy. Well, that hardware redundancy comes from having multiple physical hosts associated with the environment and gives you that kind of protection that you need if you do have a physical failure. So if one of those hosts goes away that your Unity VSA is sitting on, it will automatically be restarted over on one of the other physical devices in that cluster. VMware advanced features. So the first advanced feature that's associated with this type of environment is high availability. That's just what I spoke of as far as that hardware redundancy goes. So that high availability is the feature or advanced function within VMware that allows you to have your Unity VSA restart automatically on another physical host. Another is storage vMotion. Storage vMotion allows you to take a virtual machine and migrate it from one storage platform to another without interruption to the host. The problem is that the EMC Unity VSA is not supported to be done online with storage vMotion. They ask that you take it offline in order to migrate it from one data store to another. The reason for this is because it can cause performance issues, degradation, or loss of data or corruption due to that migrating machine. Another advanced VMware feature that you can utilize is vMotion. Again, it is recommended to have the Unity VSA offline in order to do a vMotion. Another very useful function of a VMware cluster with vCenter over the top is the fact that you've got multiple network devices that you can deploy and utilize across this infrastructure. This gives you a lot of redundancy and connectivity options when it comes to the networking side. VSA also supports multiple VMware storage integration functions. One of those integration functions is the vStorage APIs for Storage Awareness, or VASA. What that does is it does a detection of the underlying physical hardware and can provide information about the speed, class, and RAID configurations of the storage that's underlying. It has several other useful functions as well, but those are the kind of the highlights. Lastly, you have the VMware vStorage APIs for storage integration, or VAAI. What this does is it takes the efforts of doing snapshotting and things like that and puts the overhead associated with it onto the storage array as opposed to the ESXi hosts. What that means is it utilizes the functionality of the SAN to do the copies, and it accelerates the copies or clones or whatever the case may be because of the fact that it can talk directly to the storage array and have the storage array provide that functionality. The standalone physical host. As you see in the diagram on the right hand side, we've got a single physical host with multiple disks. The only real protection here is the fact that you've got multiple disks in a RAID configuration. But where does this fit? Well, number one, it's got a very low requirement for deployment. So you can utilize something like this for a remote branch office or a very small test dev type of environment, and it really gives you some level of functionality, but you're able to deploy it in a very simple, low cost, effective way. Like I stated though, there is no hardware redundancy other than in the disk drives and the RAID configuration that occurs there. And there are absolutely single points of failure with this type of deployment. No matter what you do, you're not going to be able to get enough redundancy in this type of infrastructure to really protect yourself the way you should be. So you need to really have an understanding of the use case associated with this kind of deployment. Lastly, we want to cover the things that are not supported as part of a Unity VSA. So a VSA can be used for a lot of different use cases. That virtual storage appliance really can be pretty flexible, but there are limitations that we have to be aware of. And some of those limitations are some of the greatest features of VMware. But in this particular case, they're just not applicable. The following list are features that are just not available as part of the Unity VSA. They're features inside of VMware that you would normally utilize in your regular infrastructure, but just aren't applicable to the type of machine, this type of workload that we're working with. So the Unity VSA does not support the following. Fault tolerance. So inside of VMware, there's a capability called fault tolerance. That allows you to take a machine and basically create a real-time replica that is on and functioning and running, just not in an active state. So if your primary virtual machine does fail, that other machine takes over immediately, and you generally lose less than a single ping's worth of connectivity. And then you're up and running and functioning just like you were. Because of the nature of the workload of the Unity VSA, you simply cannot use the fault tolerance capability. Because it's trying to serve data and you change that path, you can have all types of issues. You just simply can't use fault tolerance with a Unity VSA. Next is VM replication. So while this is a VM, just like any other virtual machine, the recommendation is that you not try to do VMware-based replication. The same reason that we talked about for fault tolerance, when you're doing replication, you're taking snapshots or you're mirroring data, and it just gets to the point where you're trying to serve data and mirror data, and it causes too much stress on the virtual machine that's running it, whether that be the host or the guest, and it just does not function as expected. So in order for EMC to provide any type of real support for the Unity VSA, they had to put these limitations in place, and VM replication is one of those that they do not support. VM snapshots. So what you're used to doing any other time, backing up a machine or taking snapshots so you can do upgrades, whatever the case may be, just is not, again, supported as part of the VSA. Again, a relationship to the type of workload that it is. Inputs and outputs of data, snapping that memory state will cause problems and can cause corruption. Backups. Because backups utilize the snapshot technology in order to capture the state of the machine, we are not able to do a standard backup unit using Unity VSA. You can, however, take screenshots of the configs in order to rebuild that guest machine if you needed to in the future. Because of the fact that it's using separate disk, you could possibly have an instance where you could lose the Unity VSA controller, but you don't have to worry about the data underlying being lost. Because of the fact that it's done through segregation, you don't have to be concerned with those two being tightly coupled. So taking a backup of the machine really doesn't have a lot of value. You're better off doing replication if you're concerned about the data, or taking snapshots of the config if you're worried about the actual Unity VSA appliance itself. Lastly, the VM suspend capabilities. When you have a virtual machine that's running, if you look in the options for that machine, the power options specifically, you'll find power on, restart, stop, suspend. So suspend can be really, really useful if you're doing work with a workstation or you have very specific use cases for a server. But when you have something like a VSA, a storage appliance, when you try to do a suspend, it's going to halt all the data writes. And because that is so sensitive and there is so much risk associated with interrupting data flow to a storage appliance, the risk is very, very high for you to cause some type of corruption or some type of data loss whenever you're trying to do a VM suspend on something like a storage appliance that's been virtualized. So you want to stay away from that feature as well. So if you look at this overall list, these are all great features that VMware provides, but because the type of workload these virtual storage appliance really brings to the table here, we just cannot use these features. I am sure if you tried to use them, they'd be successful, but you will not get support from EMC in any way, shape, or form. And I guarantee you, you will have a lot of difficulty getting hold of people in the community that would provide a lot of assistance just because of the fact that it is clearly presented as part of the deployment that you should not use these VMware features. So if you do try to use these, just be cautious that they are not supported in any way, shape, or form and can really cause you problems in the long run.